And you should be starting with the warm-up. So here's what I'd like you guys to do. Just put the video on pause for a second. You have 2 warm-up problems. I want you to see if you remember how to solve these problems without me working them out. When you turn the video back on, I will work them out so you can see if you've done them correctly. So hit pause. Okay, you should be back from pause now. So when I look at this, my goal is to get rid of that log. I can't get rid of it as is, so I have to rewrite it. So this, oops, I'm going to change to blue ink. So this would be 5 to the negative 3 power would equal x, which means that x is going to equal 1 over 125. So there's your first answer. For the second answer, there's a log on the left and a log on the right. They cancel each other out, so I'm left with x plus 2 equals 4x. Get the x by itself. So 2 would equal 3x. 2/3 would equal x. And since this is a log problem, I need to make sure that I take that 2/3 and I plug it in to each argument and I do a check. I should have done the same thing here. I did it in my head but forgot to tell you to make sure that that argument works also and check. So that is a little review of what we've done so far. So today we are going to continue, and if you read your learning target for today, we're going to simplify and evaluate using properties of logs today. And we're going to solve using those properties of logs. So we've got to figure out a couple of properties and make sure that everyone knows what's going on. So the first thing that I'm going to do is I want you to remember something. Remember, I said that logs and exponents are related. So I am going to ask you, if I gave you x raised to the 2 power times x raised to the y power, do you guys remember what to do with those exponents? I hope somebody said yes. I hope that you said, hey, you have to add those. That's to the 2 plus y power. So if things are being multiplied, we end up in atom. So the same idea is going to happen in logs. Do you see how a and b are being multiplied here? And the easy way to break them apart is it goes into a plus and a plus. Okay, so that's the first thing that you guys need to be able to see. From a log, we can break it down into addition. Or you could reverse this and start off with a log of A plus a log of B, and it would equal log of A times B. You can go forwards and backwards, and that AB is the whole argument. So this is a rule that you need to know, what I'm going to call forwards and backwards. So looking at this is log base 2 of 5 times 6, written as log base 2 of 5 plus log base 2 of 6. Again, you need to know how to do that. So this is using the product property. We're going to solve problems having to use that. So when I look at example number 1, I see there is 1 log on the left. That's awesome. I can cancel that out. But there's 2 logs on the right. I can't cancel that. So I need to remember, and I'm going to put this in a different color so you guys see this, only, oops, my pen did not change color, only 1 log, and I stressed this on Friday too, 1 log cancels on each side. So that is something that you need to remember, that you can only cancel 1 log on each side. Muy importante. Okay, so here we go. I have to rewrite this side. And from our new rule, this changes to log of, L-O-G. Sorry about that. And the 3 is now times the 5 as in the argument. And this other side stayed log and its base is 4 of x. And I have to come back here. I omitted my 4 over here. And now you can see that the log from the left cancels with the log from the right. And I'm left with x equals 3 times 5. So x is going to equal 15. Now, just like we did on Friday, you need to check, is it a positive? Is it a positive? Is it a positive? Yep, check. It works. Okay, so that's the idea behind these. So this one's going to get a little bit harder. This one has log base 5 plus log base 5 equals log base 5. The right side's ready to go. It only has one log. So on the left side, I have log base 5, and my y minus 4 is going to be times my y plus 4. And that is called condensing logs. And once we condense logs, I have a single log on the left side and I have a single log on the right side. You guys can drop logs. And I am left with y minus 4 times y plus 4. And it's going to equal 84. Now, how do you solve this? You guys need to remember you have to factor this. So factoring, they're conjugates. Do you guys remember what happens with the conjugates? The middle terms cancel out. This becomes y squared minus 16 would equal 84. I can now move the y squared by itself. Y squared is going to equal 100. And y is going to equal plus or minus 10. But remember, we need to bring this plus or minus 10 back up and check the arguments. Negative 10 does not work. So only don't know what that did. I'm going to get rid of that stuff. Turn my pen back on. Boom. Okay. Only positive 10 works. Okay, no negative 10. So, got it. On to the last example of this. Now, notice, I have a log here on the left. I have a log here on the left. I have no logs here. Regardless, let's condense this down to get this to be one log. So I'm left with log of base 10 to the x times x minus 9 power, or x plus 9 power, is going to equal 1. Now, the question that we asked on Friday, how do you get rid of this log? You can't. So if you can't drop the logs like we did in examples 1 and 2, what's the other way to do it? Rewrite this exponentially. So this becomes 10 to the first power would equal x times x plus 9. Okay, now think about that for a second. If there's not a log on the left and there's not a log on the right, you can't drop logs. So I had to rewrite it exponentially. So 10 is going to equal x squared plus 9x, and now we've got a quadratic. So what does a quadratic always have to equal before you can solve it? I would say that it's got to equal 0, so x squared plus 9x minus 10. And with that problem, I can now work that out. I can factor that into x plus 10 and x minus 1. And that means my x values would be negative 10 and an x value of positive 1. Okay, don't forget, we got to check. So I bring that back up. Works, yay. I bring that back up, and it works, and whoa, wait. Kendall made a mistake. Does this one work? No, it gives us a negative argument. So it does not work, and the only answer would be positive 1 is my solution. Okay, so that happens when we add problems. So notice, plus sign in between the logs. What's going to happen if we subtract problems? Well, the one thing that I want to remind you is that there's an exponent rule that says, oops, that was my puppy, and I'm going to write remember. If you had an exponent of x raised to the third power over x raised to the y power, you could rewrite this as x raised to the 3 minus y power. Here's an exponent rule. Look at the new log rule. The log rule says, hey, if I start with division, I can rewrite it. Notice the top number is the positive and the bottom number is the negative. Okay. You also need to be able to go backwards, just like we had to with the other rule. If I start with log of x, subtract log of 2, you need to know that that's the same as log of x divided by 2. Okay, so again, forwards, backwards, because now we're going to zoom up to the next page, and as we do that, you are going to see that it wants you to use a quotient property. That's what we just talked about in the previous page. So since this has a subtract sign in between it, and it's 1 log on the left, 2 logs on the left, 1 on the right, the 1 on the right is ready to drop. This one has to be condensed down to a single log. So this condenses down to log base 8, and then the positive number on the top, the subtract the negative number on the bottom. So notice, x was positive term, the 3 had a minus sign in front of it, negative term. So log of base 8 of x over 3 equals log base 8 of 5. And then whammo bammo, drop your logs. And I'm going to be left with x over 3 equals 5. Now, how are you going to solve that? If I multiply each side by 3 to get rid of that fraction, I end up with x equals 15. And again, you need to remember, check your work. Check, it works. Okay, so let's take a look at example number 5. Single log on the left, looks good. This double log over here on the right, we need to rewrite. So log base 3 of 4 is going to equal log base 3 of 6 over x. Positive number on the top, negative or the subtract one on the bottom. We have single log on the left, cancels with the single log on the right, and then we can make this 4 equals 6 over x. I am going to multiply each side by x to get rid of that fraction, And then when I'm finished, I have 4x would equal 6. X would equal 6/4, which you guys should be simplifying down to 3/2. One last thing before I say I'm done. Take that answer, check it, check it works. So we've talked about logs on or multiple logs on the left and right. Now we've got to be able to rewrite them as a single log. But we've been pretty easy so far because we haven't put any numbers in front of the log. So there is another exponent rule, and I'm going to look at the rule itself this time. So I'm going to highlight it in yellow. And notice it says if there's an exponent hooked onto the argument, so notice this is the argument, exponent hooked onto it, the exponent can come down here in front. Or vice versa, if there is a number out in front of a log, oops, the G just does not want to write, of a log base B of 5, that's the same as I can move that 3 to get that log by itself. And when I move that 3 up, it becomes log base B of 5 raised to the 3rd power. So coefficients in front of a log become the exponent of the argument. Okay, look at this example, explains the exact same thing. I went forward, it goes backwards. So this power property is what we're going to look at for this next one. I can't drop logs because there's a 2 in front of this log. So how do I get rid of that log? That 2, it comes up in front. So this gets rewritten as log base 4 of x, and notice it is just the x that's squared, equals log base 4 of 9. By moving that 2 up, single log on the left, single log on the right, they cancel each other out, and I'm left with x squared would equal 9. And you guys know that you just have to take a square root of each side, and I am going to get x equals plus and minus, don't forget that, 3. But now, when you do your check, does negative 3 work? Nope. Only positive 3 is a solution. Okay, you guys need to make sure that you're checking your work. Okay, so let's take a look at the next one. Single log on the right looks good. Single log on the left, but there's a 4 in front. I can't have that 4 in front. So where does it go? On to the back. Okay, log base 7 of x to the 4th power equals log base 7 of 1 over 81. Got it. Okay, now it's a single log on the left that cancels with a single log on the right. I'm left with x to the 4th would equal 1 over 81. Need to get rid of that 4th root, so I need to use a 4th root to get rid of that 4th power. 4th root everything, but you guys need to remember, and here's another place where people make mistakes. When it's an even, the plus and minus appear. When it's odd, it doesn't matter. 4th root of 1 is 1, 4th root of 81 is 3. So I ended up with positive 1/3 and negative 1/3. But again, remember, gotta do a check. Only positive 3 1/3, only positive 1/3 works. Okay? So, here's what I want you to do. Again, I want you to hit pause. You're going to hit pause, and then you're going to try the next 4 problems. And It's a little bit of everything. Sometimes I might mix one or two different things together and you might have to deal with it. You're okay trying it. Put it on pause, stop, and then you can go through it real fast and you can see the answers. So I'm pausing. Okay, so now that you're done pausing, let's see if you did these correctly. For this first one, since it's a plus sign and there's 2 logs on the left, I need to rewrite that as log base 10 of 7 times n minus 2 is going to equal log base 10 of 6n. I get that single log on each side. Boom, boom, gone. And I'm left, and I'm going to do a little multiplying here. 7n minus 14. I distributed it. Equals 6n. Guess what? N is going to equal 14 when I am finished. Guess what? One last thing you got to do. Check. Cha-ching. Works. So, problem number 1. For problem number 2, single log on the left, single log on the right, but there's this 3 in front. Got to bring it up. So, the left side needs to be rewritten as log base 7 of x to the 3rd power equals log base 7 of 27. Okay, so single log on the left, single log on the right, got it. And I'm left with x to the 3rd equals 27. I need to get rid of that 3rd power, so I take a cubed root of each side. And when I do that, x is going to equal 3. Do a quick check, and ta-da, it works. Okay, 2 more. So this one has a minus sign hooked onto it. So this left side needs to be rewritten log base 10 of m plus 3 all over m. And that's going to equal log base 10 of 4. Okay, single log on the left, single log on the right. They're gone. M plus 3, ooh, that plus sign didn't work, over m equals 4. Now, I am going to get rid of that m on the bottom. I'm going to multiply each side through by m. And when I'm done, m plus 3 would equal 4m. Working that out, 3 would equal 3m. 1 equals m. Got to do a quick check. Whoop. Ooh, wrong color. Check. It works. Pitching works. Last one. This one has a couple of things. Left side looks good. So it is going to stay log base 9 of x. Got it. Equals. But this right side, it has a coefficient here. Bring it up. It has a coefficient. Bring it up. And it has subtraction. Okay, so I have to bring up the exponents, if I can spell it, and then I also have to rewrite the subtraction. Okay, so this is going to become log base 9 of, you ready? 144 to the 1/2 power all over 8 to the 3rd power. Okay, so the new stuff for today, log, gone. Got it. I am left with x equals, oh, I don't like this power. We talked about this. Remember the root of the exponent? This is the square root of 144 over the cubed root of 8. which turns out to be 12 over 2, which is 6. Okay, I end up with an x value equaling 6. Don't forget, you got to do a check. Check, it works. Okay, so tonight, your assignment is out of the book. You can ask the sub and you can take pictures with your phone. I will also ask the sub to put it up on the Elmo for you so you can sit there and work. You need to make sure that you are working really, really hard on this. Make sure that you're trying to understand it and that you check the answer key that I posted on the Google Classroom. So, you guys have a great night tonight. I won't be in tomorrow, and you're going to have another video lesson tomorrow. So, if you like to work ahead, you can look at the video lesson this evening and you can use tomorrow's work time. So, get something done and be ready to ask me questions on Wednesday. Good luck.